Distance and displacement are not the same. In this video, you are going to learn the following. What is distance? What is displacement? What are the properties of distance and displacement? And, finally, the displacement in one-dimensional and two-dimensional motion. Let us start with distance. I am considering a car on a road. The car moves on the road and arrives here. From here to here, the length of the road is 1 kilometer. From here to here, 1 kilometer, and from here to here, 1 kilometer. So, the length of the path traveled by the car is 1 kilometer plus 1 kilometer plus 1 kilometer is equal to 3 kilometers. This is the distance traveled by the car. So, the distance is the length of the path traveled by an object. Since length is a positive number, distance is a positive number. So distance cannot be negative. From this distance, you cannot tell in what direction the car moved. So distance has no direction. There is one more property for distance. To understand that, I am taking an object, and the object needs to go from here to here. There are two paths, path 1 and path 2. The object can take this path, or this path. This is the initial position of the object, and this is its final position. You see that path 2 is longer than path 1. So the distance travels by the object on path 2 is greater than the distance on path 1. So, distance depends on the path, longer the path greater the distance. So, there are three properties of distance. Distance is a positive number, distance has no direction, and distance depends on the path. Next, we will focus our attention on displacement. I am considering an object on a circular path. This is the initial position of the object. The object moves on the path and returns to the initial position. So, the final position is same as the initial position. What is the distance traveled by the object? The distance traveled by the object is the length of the path, which is the circumference of the circle. You see that, at the end, the object is not displaced, because it is at the same position where it was before. Next, I am taking the same object. This time, it moves on the circle and arrives here. This is the final position of the object. The distance traveled by the object is a part of the circumference. Now, you see that at the end, the object is displaced from here to here. This arrow represents the displacement. Note that here there is no displacement, as the initial and the final position of the object are the same. This arrowhead tells you that the object is displaced from here to here. So, the displacement has a direction. The length of this arrow is the size of the displacement, which is called the magnitude of the displacement. So, displacement has a magnitude and a direction. Any quantity that has a direction is called a vector. So displacement is a vector. To find the displacement, we just need the initial and the final position of the object. It doesn't matter what path the object takes to go from here to here. For example, here there is another path. So, if the object takes this path, or this path, its displacement is the same. So displacement is independent of the path. These are the properties of displacement. Next we will look at displacement in 1D motion. In a one-dimensional motion, an object moves on a straight path. And, we consider the path as the x or the y-axis. This car is moving on a straight road, so it is in one-dimensional motion. I take the path as the x-axis. This side is positive x and this side negative x. So the car is moving in the positive direction. And this car is moving in the negative direction. So, in a one-dimensional motion there are only two directions. A positive direction and the negative direction. The positive direction can be north, south, east or west, or anything else. If you take the north as positive, then the south will be the negative direction, and so on. Now, I am taking an object. This object moves in the positive direction and arrives here. This is the initial position of the object, and this is the final position. The displacement of the object is from here to here. Here there is another object. This object moves in the negative direction, and arrives here. This is the initial position of the object and this is the final position. The displacement of the object is from here to here. Next, I am going to find the magnitude and direction of each displacement. The magnitude of displacement is the length of the arrow, which is 1, 2, 3, 4 meters. And the direction of displacement is positive. The magnitude of this displacement is 1, 2, 3, 4, 5 meters. And the direction of displacement is negative. Next, I take the initial position as x1, and the final position as x2. For this object, this is x1, and this is x2. Next, I'm going to find x2 minus x1. For this object, x2 is 4 meters, minus x1 is 0, is equal to 4 meters. For this object, x2 is negative 2 meters, minus x1 is 3 meters, is equal to negative 5 meters. This number is positive. The positive sign is the direction. And 4 meter is the magnitude. Here you got a negative number. This negative sign is the direction. And 5 meter is the magnitude. So, x2 minus x1 is nothing but the displacement. Final position minus initial position is the change in position. We write this as delta x. So, displacement of an object is the change in position of the object. Next, we will look at displacement in two-dimensional motion. I'm considering an object. First, the object moves due east and travels 12 kilometers. Then, it moves due north and travels 5 kilometers. This is a two-dimensional motion because there are two different paths, not one straight path. This is the initial position of the object. And this is the final position. The displacement of the object is from the initial to the final position. Next, we are going to find the magnitude and the direction of the displacement. This angle is 90 degrees. So we have a right triangle. And this side is the hypotenuse. So, the magnitude of the displacement is just the length of the hypotenuse. We can use the Pythagorean theorem to find the hypotenuse. So, the magnitude is equal to square root of 12 squared plus 5 squared is equal to square root of 169 is equal to 13. The unit is kilometers. Next, we need to find the direction. If you measure this angle, you will get 23 degrees, approximately. So, the displacement vector is 23 degrees north from the east. So, the direction of displacement is 23 degrees north of east. So the magnitude of the displacement is 13 kilometers. And the direction of the displacement is 23 degrees north of east. Note that, in a 2- or 3-dimensional motion, an angle is used to represent the direction of the displacement. But in 1-dimensional motion, a sign, positive or negative, is used to represent the direction.